Good afternoon, everyone. My name is Kara Smith. I'm a neurologist and movement disorder specialist at the Med campus. The thing is working. Okay, great. Today I'm going to talk to you about speech, which is a multifaceted signal that involves both motor and cognitive symptoms in people with PD. So typically, the symptoms of PD are separated into the motor symptoms and the non-motor symptoms. One of the most common motor symptoms is voice and speech dysfunction. This is typically characterized as hypokinetic dysarthria. It's caused by problems with motor control and coordination in the muscles of the vocal apparatus with bradykinesia, rigidity, and incoordination. However, other non-motor symptoms can also contribute to the speech and communication impairments that these patients have, especially cognitive impairments and mood symptoms, as well as respiratory control. We can measure the speech signal and use this as a detailed and quantitative approach to understanding speech and communication symptoms in Parkinson's disease. And we can elicit many different aspects of the speech system and its component subsystems by looking at the acoustic signal. Traditionally in the research, the acoustic measures are kind of divided into two worlds: the speech motor symptoms, which are currently studied in parallel with the motor symptoms, and the cognitive linguistic acoustic measures, which are usually studied in association with the cognitive status. However, in the real world, when we're having conversations, there is overlap between these two worlds. And if we actually study and capitalize on the interplay, we might be able to develop more personalized and more useful speech measures. My main research focus has been on the identification of speech measures of mild cognitive impairment, or MCI, in people with PD. Only a few studies in the past have really looked at acoustic measures associated with MCI and had many limitations. So I conducted the SLAM PD study, enrolling about 50 participants, half with MCI and half with normal cognition. And we put them through a battery of cognitive tests so that we could categorize them according to the gold standard in the field. Then we put them through a bunch of various degrees of cognitively demanding speech and language tasks, and including dual tasking. That way we can make sure that our speech experiments were tailored to actually investigate the cognitive domain and actually be able to disentangle the cognitive from the motor impacts. This just shows some of the findings that I can go into more detail on, but in the interest of time, I'll just try to summarize them all here. So to highlight some key findings from the SLAM PD study, so first we found that there were several subsystems of speech acoustic measures that were different in the PD MCI group compared to the PD normal cognition group. And these included laryngeal markers, articulatory markers, and energy-focused speech acoustic measures. And those were all more decreased in the PD-MCI group compared to the normal cognition. We also noticed, secondly, that this change was task dependent. So if you had a more cognitively demanding speech task, then you would see more of a decline in the MCI group. So here we're looking at vowel articulation with a picture description task, which requires more cognitive demand. The group with PD-MCI had more difficulty with vowel articulation, but compared to a reading task or sustained phonation. But in a normal cognition group and in controls, the performance was relatively similar all throughout. We took many different speech measures, or acoustic measures rather, and using machine learning approaches, looked at just what was associated with the picture description compared to the reading. So this is clearly more revealing for trying to detect the PD-MCI. And putting everything into a machine learning model, the fusion result was that there was an area under the receiving operator curve of 0.82. So this is in publication right now. And then so the future directions are that speech markers could provide a really useful novel tool for screening and monitoring PD-MCI. It could be remote, it could be non-invasive, and much less expensive than the modalities that we currently have in the biomarker space. So I'm hoping to develop this more And I'll just kind of show some future directions, which includes longitudinal study of these markers to see if we can detect who will progress from MCI to dementia status, comparing Parkinson's speakers to other neurodegenerative diseases like Huntington's disease, and looking more closely at the dual task paradigms to see if we can utilize those more effectively. So I'm out of time, so thank you so much.